So in this video, I just want to go through one example of how you can use the calculator as efficiently as possible to find a limit numerically. So as you know, if we're finding a limit numerically, it means we're sort of filling in a table, right? So for this limit I want to do on the right, I want to do the limit as x approaches 1. So if I want x to approach 1, I need to set up the x side of my table, these values over here, so that I'm approaching 1, and so that I'm approaching 1 from both sides. So I'd like you to sort of pause the video, think about what values you would plug in so that you could approach 1. Okay? So your values may be different from mine, but this is what I'm going to go with. I'm going to go with 0.8, and then 0.9, and then 0.99, and then 1. And then I'll have sort of from the other side, maybe we'd have 1.2 and 1.1 and 1.01. Whenever I do this, I sort of set it up so that I start a little bit far away and I get closer, and then I get really close, and then I actually try the number itself to see what's going to happen. Okay? So as I read down the table, I'm approaching 1 from the left. As I read up the table, I'm approaching 1 from the right. So now what I need to do is I need to take all of these values over here and I need to plug them into this thing and then sort of look at what happens over here. So the calculator I'm going to be working with is the TI-84 Plus. The operating system it has is 2.55. If you don't have that, let me know in class and I can update your calculator for you. So the first thing you have to do, hit mode on your calculator, which is right next to the second button. So hit mode and make sure that you're in radian mode. If you're in degree, switch to radian. Everything you do for calculus in this class is going to be in radian mode. So once you're there, we can hit second and quit to get back to the home screen. Now, I fear that what most students would do is you guys would do something like this. You would go sine, and then you go, okay, well I need to do sine of 0.8 minus 1 parentheses divide parentheses, and I would be happy, remember the parentheses, divide parentheses 0.8 minus 1 parentheses enter. You would do all that and you would get this answer. You'd get like, okay, this was, and I'll put it in my table, 0.993346665. There's nothing wrong with that. Whoops. Nothing wrong with that. You did fine. The problem is you now have to type that again for 0.9 and then 0.99 and 1 and 1.0, all of these values. Some of you may know that you can hit the up arrow key to sort of go back and do this again, but even that isn't as good as the trick I'm going to show you. This is amazing stuff. So be ready. We're going to hit y equals. Now you guys have used y equals. You've always used it for graphing. Hit y equals. I'm going to do something different. I'm going to type my function in there. I'm going to type in the sine of x minus 1 divided by x minus 1. Okay, and there it is. Now I'm going to do something strange. I'm not going to hit graph. I'm going to quit back to the home screen. I want you to know what I just did is I stored this equation into my y1. So when I quit back to the home screen, I'm just going to tell the calculator to plug these numbers into y1. The question is, how do you do that? If your calculator is updated, you see this F4 key up here right next to calc and trace. If you hit alpha F4, it brings up the Y menu. And you can type in y1 and then think about it. How do we plug things in? Like using notation, we would say like, oh, I want f of 2. You can actually use that notation with the calculator. You're just going to tell it to do y1 of 0.8. When you do that, it'll come back and give you this exact value. So now when you want to do 0.9, you can either do alpha f4 to bring up y1, and then do parentheses 0.9, enter. When you do that, it comes back and says, oh, well now this one is 0.99833416665. I'm getting a lot more digits here than I really need. I feel like I got an extra one there. Oh well. So yay, we did that. You can also save time by just doing second, and then the enter key, and that'll just bring up the previous line. When you have that, you can just scroll back and put a 9 in there. When I put in 0.99, the thing comes back and tells me it's 0.99998333334. Lots of numbers in there. What I'd like you to do is, if you have a calculator at home, pause the video now and fill in the rest of these numbers, or your numbers, and sort of see what you end up with. So when I plug in 1 over here, when I do second entry and plug in 1, 1, and then delete the rest out. It's going to come back and give us an error, a division by 0 error. Okay, so what does that mean? That just means that this was undefined. Okay, so we'll go on and we'll do 1.01. So second entry, 1.01. And I'm going to sort of fill all these out at the same time to save myself some time. So now I'm going to do 1.1. And then I can do second entry and I can do 1.2. And all these numbers can go over here in the table. And it turns out, I don't know that I would say coincidentally, but it turns out there's some symmetry happening here, and all the values we got before are the same values we're going to get again. Whoops. Okay. So your finished table looks like this. Now we need to finish this video. We need to answer the question, right? So what is this limit, right? What are these y values approaching? And I hope it's clear to you. This one here was 0.993. Then it was 0.998, then it was 0.99998. These values here seem pretty clearly to be getting closer to 1, right? These ones as well. This was 0.993, then 998, then 99, lots of 9s. These are also approaching 1. So from both sides, it looks like this limit is approaching 1. So we say this limit is 1, right? So you can use the calculator to speed up these tables and computing these things significantly. Hope that made sense. If it didn't, please write down what your questions are, especially if you have a different calculator version or something else came up. Be sure to ask about them.